Let us do question 3 of exercise 8.2. In this question, it is given that ABCD is a rectangle. PQRS are the midpoints of the side AB, BC, CD and AD. And we have to prove that PQRS is a rhombus. Let us join PQRS. We have to prove that this is a rhombus. Let us join A to C. Now, we will apply midpoint theorem in this question. So let us start the proof of this question. Take triangle ABC. In triangle ABC, we will apply midpoint theorem. Midpoint theorem states that if the midpoints of two sides, the line joining is parallel to the third side and is half of it. And we are taking this triangle ABC. P is the midpoint of AB. Q is midpoint of BC. Then by midpoint theorem, the third side AC is parallel to this line joining. PQ is parallel to AC and PQ is half of AC. By the midpoint theorem, call it equation number 1. Similarly, now we will take the triangle ADC, this one. Similarly, in triangle ADC, S is the midpoint of AD by the same procedure. R is the midpoint of CD. Now this implies SR parallel. The line joining is parallel to the third side AC and is half of it by midpoint theorem. Midpoint theorem. Now call it equation number 2. What implies from equation 1 and 2? Equation 1 and 2 implies that PQ and SR are parallel to the same side and are equal to the half of the same side. So they are equal to each other and they are parallel to each other. So from 1 and 2, PQ is parallel to SR and PQ is equal to SR. And when one opposite side is parallel and equal, then this becomes a parallelogram, and hence this implies PQRS is a parallelogram. Firstly, we will prove parallelogram. After then, we will prove a rhombus. Now, what is the difference between parallelogram and rhombus? Rhombus, all sides are equal, and parallelogram, opposite sides are equal. So, if we prove that adjacent sides are also equal, it will become a rhombus. Now, as we have done by the diagonal AC, let us draw the diagonal BD also. Right? Now, if we take triangle ABD, now in triangle ABD, we apply the midpoint theorem. ABD, S is the midpoint of AD, and P is the midpoint of AB. This implies PS is parallel to the third side. PS is parallel to the third side BD and PS is half of BD by midpoint theorem. Right? Now call it equation number 3. See the equation 1, 2 and 3. Firstly, we will write in a rectangle, as ABCD is a rectangle. In rectangle ABCD, diagonals are equal. Because it is a property of rectangle that the diagonals are equal, this implies AC is equal to BD. So we will apply this in equation number 3. Put this in equation number 3, we will get PC we will put over here. PS is parallel to BD. Parallel we will not take. PS is half of AC. The value we are putting. Only the value of AC. Parallel condition will not be same. PS is half of AC. Using in 3, this diagonals are equal. Now PS is half of AC and SR is half of AC and PQ is half of AC, and similarly if we take the other triangle with BD, we can prove the fourth side also, that will become the half of AC. So from equation 1, 2 and 4, it implies PQ is equal to PS is equal to SR, and opposite sides of parallelogram are equal, so we can take PQ, PS, SR, and we can take QR also. From 1, 2 and 4, and the property of parallelogram also. So all the four sides are equal, hence PQRS is a rhombus, and hence we can do this question.